Hi everyone, in this video I will show you how I've made this animation by retargeting a motion capture onto a proper control rig. Then I will show you how to make advanced ground matching for the feet of the character and also procedural leaning. I was contacted by James Candy from Classy Dogs Film as he's working on a short animation based on the Titanfall franchise. He asked me for help to bring more weight into his run cycle animation onto this big robot. I've also added a couple of secondary motion onto the character. Before we start, I'd like to thank Brad Clark from Rigging Dojo as he called me and gave me a lot of tips to edit motion capture data and open me to new techniques. Let's get started. The first thing I wanted to do was to retarget the current animation onto a proper controller rig. The motion capture data was generated using Mixamo, and we can see some strange deformation and glitch because it was based on a human run cycle. The first thing we can notice is that the deformation bones of the legs are not aligned with the current geometry of the legs. But the model was properly skinned to the armature and also used secondary controllers like MTs to control the hydraulic pistons. So I've duplicated the motion capture armature. I got rid of all the bones that were unneeded, like head bones, because they were not used on this model. Then I've renamed all the bones properly so that I have the same name on both right and left, with the suffix .l for the left side and .r for the right side. To do so rapidly, I used the Ctrl F2 shortcut that allows you to use the batch rename. I could ask Blender to find the word right and get rid of it by replacing it by nothing, and do the same with the word left. From there I can rework the alignment of the different bone. I will use the geometry of the model to snap the head of the bone on the right pivot point. I've realigned the thigh bone first, and then I recalculate the roll of the shin bone using the Shift N shortcut and selected active. This way the shin and the thigh bone have the same roll. To properly align the feet, I've simply snapped the cursor to the ankle, and then I've scaled using the 3D cursor as a pivot point to 0 on the x-axis. Then I've pressed Shift N again to recalculate the roll of the bone. Then I've created a bone for each part of the hydraulic pistons. I've also added an additional bone for each bag on the character. One bone is enough, the trick is to find the right pivot point. And I did the same for the reactors on the back. This will be a cool addition to bring secondary motion. Finally, I've added a few bones to rig the antennas. A quick tip to rig your hydraulic pistons is to make each bone pointing at each other. You can do it simply by adding the cursor to the head of one of the bone and then snapping the tip of the other bone onto it, and repeat the process for each bone. To easily create new group without destroying the skinning, you can simply press Ctrl P as you will do to parent the rig to the armature, and use with empty group. This will keep the existing group, and this will create empty groups for the new bone you have created. Then I can simply assign the hydraulic parts by using full influence in edit mode and working with the newly created vertex group. They will be named automatically properly, and since those hydraulic pistons were not assigned before, they don't have weight. I just need to select them by pressing L, and then with a weight of 1 click assign. When a part of the robot was already skinned or assigned to an existing bone and I want to get rid of this, I just select the different part I want to reassign to another bone and click the little arrow near the vertex group and click Remove from all group. From there, all the selected vertices won't be assigned to any group, and I can then select the depth reactor group I have created and click Assign. If you don't do so, you will see a little offset whenever you're trying to deform this part, and we can easily identify it by going into edit mode, select one of the vertices, and see that there are two groups influencing it. So now that I found it, I can also click the remove button to remove all the selected vertices from the selected group. In the end, I get this cleaner deformation armature. In the end, the controller rig was very simple. I did create inverse kinematic legs with a simple foot roll. You can learn about it on YouTube very easily, or in my rigging course, The Art of Effective Rigging. For the antenna of the character, I used the same technique I've shown when rigging clothes in this YouTube video. You will find the link in the description. The arm is a simple forward kinematic chain with the possibility to isolate the rotation from the shoulder, as shown in my tutorial rigging a pinnable arm mechanism. Since I haven't covered it yet, let me show you how I rigged the hydraulic pistons. Each of the hydraulic parts are whether parented to one of the articulation or the other. In this case, the base are parented to the foot, the other to the shin bone. The first step is to use a dumped track constraint from the heel bone to the bones parented to the shin. Select the constrainer, then the bone to be constrained, Ctrl Shift C, add a dumped track constraint. Now the most obvious thing to do is to then add a dumped track constraint from the second bone to the first one. But the problem is that we are constraining a bone with a bone that is constraining the other, and we get a cycling dependency. And you can see a bit of lagging in the motion of the piston. Fixing this problem will be way easier than you might think. We just need to get rid of the constraint, go into edit mode, duplicate one of the bone and scale it down. And since it is also parented to the shin, I can use this bone to constrain the heel bone and use the heel bone to constrain our original piston bone. So this is exactly the same mechanism as before, but adding the third bone will get rid of the cycling dependency we have. Ideally, you will build your motion capture rig and your control rig at the same time to avoid all the steps we did before. One thing to see here is the behavior of the hips. You can see that whenever I'm moving the controller of the hips, they rotate, and I've added this root for the torso that allow me to control the whole character. While on our base rig and the motion capture rig, rotating the hips bone will act as if we were rotating the root bone, making the whole character rotate. Let's start retargeting the animation. So I will go into object mode, select both armature and go back into pose mode. You can now go into pose mode, selecting multiple armature. Now I will use the Mixamo armature to constrain my controller armature. So I will use every bone in forward kinematic and use a copy rotation constraint. So I will first select the bone from the Mixamo armature, then the bone from my armature, press Ctrl Shift C and add a copy rotation constraint from the spine bone to the hand bone. Now I want to use the hip bone from the Mixamo to control both my hips and my root torso bone. My root torso bone won't be rotating since the whole spine is using copy rotation already. What I will do is simply use the hips from Mixamo and add a copy location, and then in the constraints tab I will slide my root bone toward the tail of the hips bone, and now it's perfectly aligned, and it will drive the location of all the bones in the upper part of the body. Now for the hips, it's a little trickier since the bone is inversed. What I will do is that I will create an empty that will be snapped onto the head of the hip bone from the Mixamo armature. Then the idea is to make this empty following the hip bone from the Mixamo armature. So you can use a copy transform, a copy location, or even in this case I will use a child of constraint. And I will click the set inverse so that it snaps back onto the hip. And then I can use this empty to add dumped track constraint onto the hips. So the hips reversed will be pointing at this empty. And so they will be following the rotation of the Mixamo hips. The empty is following the hips and our controller hips are following the empty. Since we are using an inverse kinematic chain to control the leg of our control rig, we just need to constrain the foot controller. And we will use a simple child of constraint in set inverse. Any motion from the foot of the rig will move our control inverse kinematic and our whole leg. To retarget the toes, we just need a copy rotation from the Mixamo toes to our control rig toes. But since those two toe bones are not perfectly aligned, there is a bit of shifting whenever we are activating or deactivating the constraint. So what I will do instead is get rid of this copy rotation constraint by pressing Ctrl Alt C. I will go into edit mode and add an empty onto the tip of the bone of our toe controller. Then I will make this empty a child of the toe of the Mixamo rig, and I will use, as usual, a damped track constraint onto the toe bone of my controller rig. I would suggest using here not a damped track but a locked track constraint, since the toe bone on this very character, on this robot, is supposed to rotate only on one axis. The damped track constraint and the locked track constraint behave the same, they are targeting something, but the locked track allows you to rotate only on one axis, which is more relevant to this part of the character. I've then made the same thing for the right leg, so this empty is a child of the right toe of the Mixamo rig, and I'm using a damped track constraint onto our controller toe. So now if I select the animation of my Mixamo rig that is constraining our controller rig, we can see our character posing and now getting animated. So I have some glitches with the pole target of the legs, but everything is following. I just have to stuck the poles using other empties and constrain them using copy transform so that they won't be jiggling following the feet. I've parented the pole targets to the feet. This is something I usually do. In this case it was quite a bad idea and I don't recommend to do it. But it's not that hard to fix. You can see that already simply by unparenting them I get a better result. So now that my controller rig is constrained with the motion capture, I need to transfer those animation information onto it. I will simply select all the bone from my controller rig armature and I will bake the action onto it. So you just need to press A, then press F3 to search for bake, and I will select bake action, select only selected bone, visual keying, and clear the constraint. And it will create a new action and I will see my character running, but all the constraints we have built before will be removed. So now the current Mixamo animation is no longer affecting our character. So what I would advise is to keep a version of the Blender file where your character is constrained by the Mixamo or whatever motion capture data you are using, so that you can import other animation from your motion capture resource and bake them onto your control rig. Then you can give this controller rig and the baked animation to whoever is cleaning the animation in your company, or if you're doing it by yourself, clean those along the way. I will show you some of the steps I have followed to clean up my animation. First, I've started with the root of the body by decimating the keys so that I get less keyframe and more or less the same motion as the one that was provided. I generally use the decimate ratio function whenever I'm working on baked data. From there, I've reworked the left to right motion so that the leg that is currently touching the ground was pushing the torso toward the opposite direction. I had a bit of delay on this left to right motion, meaning that the extreme will be reached a bit after the foot touched the ground. Then I've cleaned the motion of the foot, so I've been working only on the left foot and then I've mirrored the animation onto the other one. It was the part of the animation that needed the most cleanup because the motion was taken from a sprinter, someone that is running very fast, so we can see that the heel of the foot is almost touching the butt, and on this character it doesn't really fit. Also, there was a lot of left to right motion because our character, or the original motion capture character, has human hips, but in our case it's supposed to rotate only on one axis. So I have drastically reduced the left to right motion and also any rotation of the foot that wasn't around its x-axis. When I've built the rig, I've made sure that the controller for the foot was aligned with world space. It makes the guesswork way easier when it comes to what axis I have to correct. The up and down will be the z-axis, the left to right will be the x-axis, etc. So like in 5 or 10 minutes I was able to fix the foot motion, but then I had to fix the pole target motion. So they were still parented to the feet because it makes more sense if you have to animate the character by hand, but in the case of this motion capture transfer, it's a bit of a problem. So what I did is that I first constrained an empty to my pole target using a copy location and baked the animation of the pole to this empty. And then I will use the empty to constrain the pole target and I will clean the animation onto the empty. It's a method I use a lot when using space switching. Since the empty is using world space and it has no parent to child relationship, it's super easy to make it stays or move just a little in a point in space. While when you have a child that is parented to the foot, for example, which has a lot of motion, it's very hard and you will be fighting with the rig on each pose if you want the pole target to stay still in front of your character. So as soon as the animation was baked onto the empty, I got rid of any backward and forward motion by making the y-axis curve flat, and I've simplified the x-axis curve and also reduce its amplitude so that I have a more subtle left to right motion. For the hips motion, I greatly reduced the rotation because it makes it look too human again. So by simply selecting the different curve and then scaling them down following the 3D cursor or using the animate add-on to reduce the rotation. Then I did add a lot more of up and down motion on the root of the torso so that we get this more robotic feeling, more weight into the motion. Then I've been working on secondary motion. I've added a bit of bouncing on the shoulder movement, and you can also see that the reactors on the back are a bit delayed. It creates a bit of overlapping motion. I've also added overlap to the antennas and to the knee pads, and finally to the bags on the leg and on the front of the torso. I've also reworked a bit the animation of the fingers that were not included in the motion capture. So this was more of an overview video. The next video will be more detailed and step by step. I will show you how to make this character following a path with procedural leaning depending on the rotation of the character, and also how to make the feet contacting the ground with no heel clipping and limited toe clipping, but it will be in the next video. I hope you like this one, and I'll see you very soon.